So as Mark said, funny story this morning. Mark and I have worked together for I think 7 or 8 years now, and we have a couple of big things launching today. So I'm up about 5:20 a.m. this morning because I'm also on East Coast time. And he says, hey, Bankum can't make it because of this flight cancellation. Can you present today at 10 a.m.? And I said, is this your idea of a wake-up call? And he said, well, it looks like it's working. So here I am. And the exciting news is that I have, as Mark said, some survey results from a survey we just ran last month. The survey had just launched this morning at 9 a.m. Eastern Time. And so you are among the first that will see some of these survey results, as well as some of the data that I'm pulling together for the State of the Software Supply Chain report that will be released later this year. And I'll tell you a little more about that. So I'm really excited to share this with you. As we think about DevSecOps, and we think about the software and the applications that we're building within our organizations, if you don't know what you're building with, there is no possibility for you to keep it secure. So today, we're going to talk a little more about what's inside your applications and how your DevSecOps teams and how leading DevSecOps teams are meeting those challenges to better understand what they're building with. I want to start with the first way of DevOps. For any of those of you that have read the Phoenix Project that Gene Kim introduced us to in 2013, the first way of DevOps is that we need to emphasize the performance of the entire system end to end and to never pass a known defect downstream. And it's this understanding and this practice that led me to do a lot of research over the last 4 years in what I publish as the State of the Software Supply Chain. And this year will be in its 4th year of this report. Every single one of your organizations has a software supply chain. And if you're not familiar with what software supply chains are, I'll give you a simple tour today through what the different stages of the software supply chain are and how they impact your organization. There are open source projects out there that act as the suppliers in the software supply chain, where you're pulling Java or Ruby or Python or .NET open source components and packages into your organization. Your developers are downloading these components and even containers, if you will, if you consider Docker Hub one of these central warehouses, from these internet-based warehouses where they're pulling down code that they don't have to write from scratch, that they can download in a second. They are pulling these open source components into your organization, which are behaving as the software factories. And they're using these components to create the finished goods or the applications that your organizations are building or selling as products or services. Every single one of you has a software supply chain operating in full effect. As I mentioned, I've documented the state of the software supply chain for the last 4 years now, and I'm going to share some of the data from that report with you and also make the report available to all of you as well. And then I'm going to share data from the survey that we just launched this morning. So to understand the massive volumes that are available and operating within these software supply chains, we'll take a look at the very start of the software supply chain, the suppliers or the open source projects. There are millions of open source projects available to every one of your developers. In the Java realm, there are over 3 million open source components. In the JAVASCRIPT realm, there are a couple million Java components. In the .NET and Python realm, there are over 1 million components available. 10,000 new open source projects get released or appear on the market every day with new versions that they're releasing. The average open source project releases 14 new versions a year that are available and accessible freely on the internet from your developers, for your developers to download. To give you a sense of the volume that is being consumed out there, at Sonatype, where I work, one of our roles in the community is that we run the Maven Central Repository. And this is where every Java developer on the planet gets their open source components and downloads those for use within the applications that they're building. In that internet-based warehouse alone, last year we saw over 87 billion download requests. There are only 10 million Java developers on the planet. If you're developing in JavaScript, I don't have the final numbers yet, but I've been following Lori Voss from npmjs.org, and they're on track for over 200 billion JavaScript packages downloads from last year. 200 billion. 3 years ago, it was 2.5 billion. The growth rate in consumption volumes is massive, and it's coming into your organization. And as a result of this behavior, the applications that your developers are building are now 80 to 90% open source components. 80 to 90% of that footprint of the application is built from code that you did not write from scratch, that you brought in from the internet because it's faster to download in a second than it is to write it from scratch. And if you're working with containers, the leading organizations are now seeing 80 to 90% of their infrastructure built from containerized applications that are out there. Docker expected last year that 12 billion pulls from the Docker Hub would occur last year, up from 6 billion the previous year. You are consuming parts and containers and artifacts from the internet to help you move at faster velocity. And it's this velocity that not only makes us more innovative and more competitive on the market, but it's this velocity that we also have to secure. There's a little secret about the software supply chains and all of these parts that make us more innovative, and that's that not all of these parts are created equal. When you download these parts, some of them have known security vulnerabilities on the day that they were downloaded. To give you a sense of what that looks like, these are new numbers we haven't published yet in the State of the Software Supply Chain report, but I've been tracking this over the years. And 3 years ago, 6.1%, or about 1 in 18 parts that were downloaded had a known security vulnerability in them. Last year, 12.1% of everything downloaded from the central repository had a known vulnerability. More than 1 in 10 that you're bringing in to your organizations has a known security vulnerability from day one. Now, none of you in any organization that I have seen is downloading 1 billion components, right? Within the downloads that we see, I analyzed about 7,500 organizations. And within those organizations, the average one was pulling in 170,000 Java open source components on an annual basis. Within that group, 11% of their downloads were known vulnerable, which equates to that 18,000 vulnerable components that have come into your organization and are used somewhere by developers. And you have to be able to assess when, where, and how those are being used to understand how we keep those secure. Now, just because that you downloaded those components or your developers downloaded them doesn't mean that you've used them. We all have, or most of us have, the majority of this room at about 60%, have open source governance policies in place that says you shouldn't download components with known security vulnerabilities. And if you do, you shouldn't use them because those are bad. And there's likely very good ones available, the newer versions of those same components that are available for you to use. So in this year's DevSecOps community survey that we just announced the results of this morning, we ask people if you are using open source components and you have an understanding of what components are being used in your organization, did you experience or did you suspect any breaches related to those components? Last year, or this year, sorry, 31% of the respondents, we had over 2,000 respondents. 31% said that they experienced an open source breach. You might think that because we just had Equifax, and that was an open source related breach, that this would be top of mind. And maybe it's that awareness that boosted the numbers considerably this year over last year. But when we ran the survey of 2,000 people back in 2014, do you know when we ran it? We ran it in April. We had about 2,000 developers that we asked the same question. And on April 7th, 2014, the Heartbleed vulnerability was announced. So smack dab in the middle of that survey, when open source awareness and vulnerabilities were top of mind globally, we only saw 14% of those organizations say that they had or suspected an open source related breach. That should have been an anomaly. At 31%, we need to be paying attention. When we ask this year, if you have an open source policy in place, and as I said, about 6 in 10 of the organizations that answered affirmatively to say, we have an open source policy that's in place. The next question I ask is, do you follow that policy? So the interesting thing was, for organizations that didn't have a DevOps practice in place or DevSecOps in practice, 58% of them said, yes, we have a policy, but only 46% of them followed it. In the mature DevOps practices, where 77% had or admitted to having an open source policy, 24% were ignoring it. In this particular case, what's happening is that open source governance policies are being automated within the DevSecOps pipeline. And when you have automation, it becomes very difficult to ignore. When the automation is integrated into the development tool chain, it becomes much more difficult to ignore. So what's happening when we ignore those policies and we're using whatever open source is available? Those vulnerable open source components are making their way into production. Not only are we being breached, but when you look at this study from Northeastern University, published last year about JAVASCRIPT vulnerabilities. What they saw was they evaluated 133,000 websites were that very popular JavaScript packages being used in these sites that had perfectly safe versions of those packages, that 87% of the instances of handlebars or 37% of the instances of jQuery were using known vulnerable versions of those JavaScript packages in production. That they weren't tracking and tracing what open source are we using and where are we using it and are there known vulnerabilities associated with it. So let's take a little closer look at what happened at Equifax. I think all of us in this audience know the story. But if you look at it from a timeline perspective of what happened, back toward the beginning of March last year, the Apache Struts project announced that there was a vulnerability within Struts 2. They immediately released a safe version of that component for organizations to download and update their applications with to prevent against breaches. Within 3 days, the hackers had found their way to a vulnerable struts component within the Equifax environment, application environment. They spent the next couple of months probing around within that environment to find access to the data, and then began to pull that data out of Equifax over the next several months leading through summer, where then the breach was discovered, emergency incident response plans were put in place, and I think we all witnessed the aftermath of that in the months since. It's that kind of behavior. They had 3 days to respond to the hackers' attempts to get into their system. They also had months to respond as the hackers were probing through that system. When we look at Gartner's research and we ask, how long is it before a vulnerability is disclosed and the hackers breach the first systems or the first exploits are seen in the wild? About 10 years ago, those exploits averaged 45 days. In this year, in 2015, the average exploits went down to 15 days. In the case of Equifax, it was 3 days. The hackers are getting faster because they're being more efficient. They're looking at the greatest ROI. Where's our biggest bang for the buck? If I can break into one vulnerable struts instance, I can break into every single one of them because the exploit path is the same for all of these organizations. Now, as I mentioned at the beginning in the title of my presentation, we are all Equifax. When I looked at the downloads of vulnerable struts components from the central repository, what we saw in the month of March 2017, the month that the vulnerability that breached Equifax was announced, we had about 100,000 downloads of the vulnerable versions of struts. Then it decreased slightly to about 80,000 vulnerable downloads per month. And it stayed relatively flat during the entire year after that vulnerability was disclosed. And what you see in November of 2017 is it peaked again to almost 100,000 vulnerable downloads. If you think that Equifax was the only one downloading and using vulnerable versions of struts, you might want to ask again within your organization what you're using, and are you using the secure versions that are available out there? Now, some of you may be saying, hey, I know for certain we are not using struts within our organization. We're using Spring, so we're good. So we also looked at the Spring downloads. And for those of you that have been following Spring, there were vulnerabilities announced just last week or within the last 10 days. There was a big vulnerability that was announced more publicly about a month ago, but it had been disclosed back in September. And we looked at the average downloads for those were about 70 to 80,000, 90,000, right? The pink bar in the middle is when the vulnerability was disclosed. The volumes, of course, don't change significantly before the vulnerability, but they don't change significantly after the vulnerability was disclosed either. We need to pay attention to what we're building our software with if we want to keep it secure. So most of you I saw earlier when Shannon asked you to raise your hands, most of you are security professionals. And in our survey, we ask, what's your feeling about security professionals? And most of the developers and DevOps professionals answering the survey said 72% of them consider all of you nags, right? You're the people coming and saying, hey, you're not doing secure things. You need to have better, more secure practices. And that's absolutely right. But in order to get the developers to follow your practices and to work with them, you have to integrate security into the development lifecycle, into the tools that they're using across their DevOps pipelines to make it easy for them to assess what they're building with and how they can make safer choices along the way. And it's these feedback loops within DevOps practices where you're checking something in, you're getting a green light, it's going to the next stage, it's getting a green light. And if you do security checks and it gets a red light, it produces a feedback loop for that developer that can then provide them information that they can take action on to mitigate that particular vulnerability. In this year's survey, we ask, where, if at all, are you using automated application security throughout the development lifecycle? The yellow bars on this represent organizations with no DevOps practices. They said we're waterfall, we're agile, we're not a DevOps shop. The purple bars represent the mature DevOps organizations, self-identified organizations. We have a mature DevOps practice. As you can see, the mature DevOps organizations are implementing automated security 335% more often across the lifecycle than non-DevOps organizations. If you think automated security throughout the DevOps pipeline is not possible, there are people that are racing ahead of you in these practices, and many of them are presenting today here at DevSecOps Days. We also ask in the survey, if you're automating security throughout the pipeline, what kind of tooling are you using within that? Web applications led the way, web application firewalls led the way, followed by container and application security and open source governance, and a number of other components. So also for all of you taking pictures, I'll tell you how to get a hold of the slides later so that you can actually have them on your desktop and not have to have funny angles like I had for taking the pictures up there. So this is where organizations are investing. And again, you can look at where the non-DevOps organizations are versus the DevSecOps practices within those organizations. When organizations practice automated security throughout the development lifecycle, good happens. In the State of the Software Supply Chain report last year, we analyzed 17,000 applications that were being developed by different organizations around the world. And although last year we saw 5.5%, or the year before within this report, we saw 5.5% of the downloads had known vulnerabilities, for those that had open source policies that were automated and governed within their supply chain, they were able to reduce the vulnerability defect ratio within their pipelines by almost 70%. By controlling and understanding what are we using, and are there vulnerabilities in this, and are we informing our developers, and is there a remediation path that we're sharing with them? And you'll hear some of the people here later today, like Fannie Mae, that are part of these kind of managed software supply chain practices. So the question is not, can we build secure software? We absolutely can. But I will tell you, next month, if you're doing business, if your company is doing business in the European Union, you have to. Secure by design is one of the key principles of GDPR, which is going to be introduced and start this regulation in, I think, May 28th, next month. You have to be secure by design. The European Union, the French government, the UK government, the German government, and the US government are all pursuing policies for software liability. To say if you are putting known defective parts, known insecure parts, vulnerable parts in your software, we are going to hold you liable for those. The UK government is already fining people for these poor design practices. And in France, they introduced policy in February that said, we're going to hold you liable for the life of the product on the market. Just as you can't put a known defective Takata airbag in a car today, you shouldn't put known defective open source components in your software and ship them to customers or make them available. So as we talk about DevSecOps, we go back to the first way of DevOps. Understand the end-to-end performance of the entire system and never pass a known defect downstream. If you want to learn more about this or get my slides or the software supply chain report or the survey, my out-of-office message is on. All you have to do is get out your phone, email weeks@sonatype.com. It will send you my out-of-office message. It has links to SlideShare where you can get the files, these slides, and download them. I won't follow up with all of you to say thank you. You don't even need to put a subject line. It will just respond back, and you can do that. It will be on all day. So thank you very much, Mark, for the opportunity and for all of you for being here.